Hello, my name is Professor Victor Chen, or you can pronounce it Chang. Today, I'm very honored to give a talk on behalf of my student. It's actually mainly for the Complexes conference between 22nd to 24th of April this year. But because of the technical error, then I do not mind to give a talk again. So the title is called the Machine Learning Techniques for Breast Cancer Detection. And I'm going to talk about the topic as the follow, starting with the background, with the research question and contribution, and then about the data set information, the model training, SVM model, and kernels and KNN models, neural networks, results, conclusion. So the background, as we know that breast cancer is the most common cancer for the woman worldwide, and the key is to improve the survival rate in early detection. And it can be done by the biopsy. So you have the needle that insert into the breast, and then the process normally is not going to take a long time. So then you can then know whether you have the breast cancer. So the biopsy is most used method, and it has also a very high level of accuracy. However, that requires a very sophisticated and very well-structured way to record the data and analyze data. As you know, that the electronic health record is increasing. There's a growing demand for the data scientists to collaborate with the clinicians to achieve this, because it's also important for the data scientists to have the knowledge and the skill in order to do the job better and to work with the clinicians. So the machine learning models have been used very effectively to analyze the electronic record, because it allows the scientists to get a result in a very high percentage of accuracy. And it's also very fast, efficient, and you can even automate the system. So in order for us to do well, so what we should focus on is whether the supervised learning models and also other machine learning models will be used to predict whether the cancerous breast tumor are whether benign or malignant, by analyzing the characteristics of the cancer cells from medical scans. So the next step after biopsy is to analyze from the medical scan. So, and the machine learning methods has been mentioned and used. So in our case, we focus on three major types. I'm going to talk about the reasons why. So that includes SVM, KNN, and neural networks. And the goal of our research is to determine what type of models are the most effective at classifying breast cancer. So it allows the scientists to get the highest level of accuracy and quality. It also allows clinicians to get the results quicker to report to the patients. So by comparing the effectiveness of our model, we can also work with those carry out in the previous research. We can always keep improving, and then we're going to work together with healthcare professionals, deliver the best tools for the breast cancer patient in order to resolve the problem together. And in this case, it's very interdisciplinary. And then the data set information was obtained from the University of the Wisconsin Hospital in USA. So it contains information about the cells of each patient, like the cell shape and size. The data also tells us whether each patient was diagnosed as benign or malignant. The combination of the cell characteristics and the cancer classification allow the machine learning models to understand the relationship between these variables. So the machine learning and models will understand better and better, and then to even identify the correlations and to understand any unique characteristic for the patient. And as we can see here, the data set information and explanation, it gives a scale 1 to 10 for most of the variable. So that includes the common thickness, the uniformity of cell size, uniformity of cell shape, marginal adhesion, single epithelial cell size, bare nuclei, and also a blend chromatin, and normal nuclei, mitosis. And also it has the predicted class 2 for benign and 4 for malignant. So when the patients is under the huge transformation in the the cancer in the breast that may lead to cancer, and normally benign means that although there are very large extent of normal cells, but usually they are on the positive side. They are not going to make a very damaging impact. Then, therefore, when the cancer cell become malignant, it means that it's going to develop into malignant tumor and it get worse and worse, and it is out of control. Then usually in the scale will determine whether whether how destructive the patient's cell will become. So they will give a very good indication, such as the medical image, whether we'll get to benign and malignant. So it will also help the scientists and the clinician to determine the result in a short period of time. So now let us talk back for the machine learning model, because we need to train. So all the machine learning model will need training. So that they will include the example of the tenfold cross validation to use in all the model training. We train the models by using the cell characteristics, such as the input variable, and then to predict the cancer classification as an output variable. And the model's performance are assessed on how they perform when given input data, but no target variable. And we use the 80-20 split for training and also the testing of data, as you can see in the diagram here. So the data set gets to training and testing in a percentage of 80% to 20%. But then in order to do a better task, and later on, we then can split into another 20% from the training, just in order to get the results in a very high percentage of accuracy. But at the beginning, we use 80 to 20% split. And as you know, the support vector machines, or SVM, is commonly used, is a kind of family of the supervised learning methods commonly used for binary classification and regression analysis. The SVM algorithms map training data to points in space in a manner that maximizes the width and the gap for the margin between the two classifications. So as you can see, this is how the SVM is performing the training. So it maps all the points so that at least that you are close enough, and there's a maximized width of gap between the next classification. So then the testing data is then mapped onto the same structure and classified in accordance to the size of the machine that perform. The different kernels can then be used within SVM models. We then can test with the linear or the radar basis function RBF polynomial kernels using the sklearn library available in Python. So we then use this, and then with the SVM itself, it has 3 variations. As the linear, as you can see in this case, you can perform linear regression, and also the RBF radar basis function based on mathematical models and polynomial kernels. Then we then use the SVM kernels as the linear regression itself, means that it doesn't perform the regression in a linear way. And non-linear regression can be performed by applying the nonlinear classification rules, and that then correspond to the linear classification rule for the transformed data point. So in this way, you then allows a very efficient regression to take place. For example, the Gaussian RBF and polynomial kernel function are being shown as follows. But then when they are not in linear, then by following these formulas, you then can calculate the movement, so they can then move to the next or the cluster. So although most of the data points are on their side, but then because some of those data point would then fall into another cluster. So let us talk about the KN model, which stands for the K nearest neighbor, is a non-parametric supervised learning model commonly used by the classification for the regression. It classifies the data used for testing based on the proximity on the nearest data points used in the testing. So it finds the nearest data points that you can see in this figure and the K value determines how many nearby data points are taken into consideration when classifying the testing data. The optimal K value can be found by checking the square root of the number of the training data sample shown in the graph. And the K model functions rely on distance matrices, so the distance matters. So if the distance is nearer, then the algorithm itself is usually more accurate. So in the case that, let's say there is a Minkowski distance function is being used, so then and to determine the final values, so then the algorithm then keep calculation and keep updating the result. And the neural networks in this case are type of the deep learning model that consists of the layer of artificial neurons, or we call it nodes in this case, as you can see in the figure, or designed to mimic a real synaptic brain network. So it's to mimic how the functions in our human brain work. And information is passed between the nodes and the layers through the connection, or we call the edges of the network. The input layer processes the input variable. In our case, this refers to the different characteristics of the cancer cells, and the weights are assigned to identify the strength and the nature of the relationship between the variable. And the hidden layers sit between the input layer and the output layer. Here, the weighted inputs are taken in, and output is produced through the use of activation functions. So then we then train the model in this way, and then we in the final output layer, then we can then calculate all the vital information about the cancers. And the result matrices, of course, it's a different machine learning model. We need some kind of matrices to identify how accurate the results are. So normally we use the accuracy we call F1 score to determine the key values, especially accuracy has been commonly used. So we use the formulations. So TP, TN, that means true positive, true negative, and also FP, FA means the false positive, false negative. So by following this formula with accuracy, then similarly we use the recall and sensitivity measures the percentage of the correct positive prediction mode made. So in this case, then we have the malignant tumor successfully classified. So this is one thing that we have to identify to focus on the malignant tumor, because by having the focus, then it allows us to calculate a more closely related result. The F1 score then calculate the harmonic mean by both precision and recall, so to give the balanced understanding of the most effectiveness. So by going through these details, then we can have the results like this. So then what we've done is that we have used different models, such as the SVM RBF, used by other researchers, and artificial neural network, and SVM linear, and SVM RBF by another group of researchers, and SVM polynomial, CAN, and decision tree. So what we have done is that we have been running a number of different machine learning algorithms, and then we then have the results through the use of accuracy, recall, and F1, which are quite commonly used in AI or ML community. So then when they have all these results, and then we made a comparison by running with different models, and we then realized that the SVM RBF in this case have highest values for accuracy, and also it has a very good result with recall in par with the SVM linear. And then in terms of F1 score, it's also beats all the others score. And not all the models are being suitable in a way, because there are models that either they only focus on accuracy but they're not interested in other result. Or it can be the case that the authors are only focused on getting the accuracy. So while we compare with different models, and SVM RBF is the one that is the most suitable and most accurate in our case. And we can see that SVM-based classifiers, in comparison with other similar models or other competitive models, it has slightly better performances than others. So the conclusion is that as the data set are becoming larger due to the increasing popularity of the electronic health records for data analysis, so different models may prove to be more effective on larger data sets. So it's the common approach is that the machine learning data scientists will need to be able to understand all different models and run them all together, and then to make comparisons and to understand which model will be giving the best or the highest level of accuracy. So then we have to also consider to develop deep learning models together with the existing model, so we can perform better on larger data sets. So the research can be conducted by taking others' approach similar to this way to explore how different models perform on varying sizes of data sets to give the direction in this regard. So the data sets may become larger and more complex in a way that we need even the combination of several models to work together, and we may have to consider other type of AI and ML methods such as federated learning. So in this regard, example models are new and cutting-edge models that integrate multiple types of model together. So one of the common approaches to combine the XG and also like GMB. They often perform better than individual models. So combining effort is always helpful. And then we can also take similar approach and also perform a better predictive diagnosis in a way that we hope to always enhance the patient outcomes of other diseases such as diabetes, because we can use the lessons learned in this case, and then we develop the better machine learning algorithms, and then we test the data. So we can also use the same principle to apply for different type of diseases, which has been quite useful in the case of the diabetes. Then please consider citing our paper if our work is relevant, helpful, or inspiring to you. And I have put down the link of a paper. Our paper, in this case, you can download it for free forever. So we will hope that the community will support our work, especially these days, machine learning and data science are working together very closely. And as you know, if you are a very skillful and experienced data scientist, will be able to work and provide lots of experiences and skills to different domains. And please consider citing our paper. Thank you so much. And I wish you all the best for everything. And thank you. Bye.